in the 5S cabinet. And we don't need a pile of Allen wrenches in that cabinet. We need only the Allen wrenches that are required to work with this machine. We don't want to have to dig through a bunch of standard size Allen wrenches if the only size is metric on this machine. We don't even necessarily need a full set of Allen wrenches at this machine. Only the 2, 3, or 4 Allen wrenches that are required to make a setup. Alright, so what I'm going to do, guys, is I'm going to mount this in first. We want to make absolutely sure that our turret is clean and free of any chips. You guys see what I'm rubbing off there, that rust? If you don't think that changes sizes, you're wrong. Make sure that there's no chips, no buildup of rust, nothing that's going to cause problems on the machine. I'm cleaning stations 1 and 2 because that's where I'm going to mount tools. Put the tapers towards each other. Start the 2 screws. And you'll see that I can slide this in and out just a small amount. Loosen that, pull it down where I've got plenty of room to mount my tool. We're working in station number 2. Tool 2 is actually the grooving tool. We mount the grooving tool. We don't want it sticking out of the turret any farther than we absolutely have to have it sticking out. We lose rigidity. We mount it and we snug up the screws that are holding the block. Alright, I'm going to index the turret up so we can take a look at some things. If you'll take a look at the mounting system, I've put the wedge in the corner of the turret station and I've pulled the lockdown bolt into the wedge. What that's going to do is cause pressure up onto the tool, mounting it securely into the station. I'm now just simply going to tighten it down into the tapers. Tapers are an odd creature, guys. We don't have to get a cheater pipe on these things. I'm tightening that with a short arm hex key with my fingers. No cheater pipes. Don't get a hammer and beat them in there. Nice and snug. Okay? That tool's not going anywhere. Next one that I'm going to mount is going to be the turning tool. I'm going to go ahead and move my turret up another notch just for ease of working. I've cleaned the station. I kind of put my wedge in there and I'll move it around a little bit to make sure there's no burrs or anything that I'm locating on. Make sure that I haven't got a problem that's going to cause me issues later down the road. I'm going to put the 2 screws in, snug them up, just starting them. And then I can mount the tool itself. Once again, you wipe out the station, you also wipe the tool off. Make sure that there's no damage to the tool, especially on the locating surface. Make sure there's not a rust buildup or even a chip that's been smashed into the tool itself. When I load the tool in, I snug up the 2 screws. I want to snug these first because I want a nice even tightening. Snug them both up with the short arm of the hex key. And then I can turn them and give them a nice even quarter turn. And then what I'm going to do, guys, is I'm just going to make sure that both of them are good and tight using the short arm hex key. It's located up against the back of the turret. It's located up against the bottom of the tool, and that tool is on center line. Any questions about the wedge tool mounting system?
From my point of view here, those things are upside down.
I'm actually going to run them turning this way on the back of the turret. I like to run my inserts insert down. Gravity takes the chips away for me. If I've got those inserts turned up, then I can possibly have chips sitting on top of my tools building heat. This is a more preferred method in industry on a CNC machine. Everybody good? Alright. Guys, what I'm going to do on the next step, that was tool mounting, cleanliness, mounting them in the proper slots or turret stations, making sure the proper tools are mounted in the proper slots. Tool 1 is the turning facing tool. Tool 2 is the grooving part off tool. Okay? I'm going to come over here to my offsets page on my display, and what I'm going to do right now, guys, is I'm going to make sure that I have no offsets in any of my offset pages. I'm simply going to origin, ask me if I want to zero all, and I say yes. I have no tool geometry. I hit my offset page again. I can do the same thing, origin yes, make sure I have no work zero offsets. Hit my offsets page again. If I had wear offsets, I could do the same thing with origin yes. I have no offsets left in my tool page whatsoever. I'm going to go to my geometry tool page. Tool number 1, I'm going to give a brief description by telling it that I have a radius on the tip of my tool of 0.0321. My bad. 0.0312. 1/32. I can enter that, and I have now described the radius for tool number 1. Tool number 1 needs a geometry offset. Basically, guys, I'm going to touch this tool off of the tool eye, and it's going to set a geometry offset for this tool. We're going to, in essence, tell it how far away from the tool eye the machine is at home from the tool eye with this tool active. So I'm going to index this tool back into the active position. I'm going to bring my tool eye down into the workspace, and I'm going to manually hand jog my tool over to the tool eye. I'm going to set the Z first by coming over close to the tool eye, making sure that tool 1 and the Z offset are highlighted, and I'm going to, with 1/1000th feed, go Z minus until I hear a beep. I hear a beep, it automatically sets a tool geometry. That tool is minus in Z, everybody remembers the minus in Z, 6 inches, 227 thousandths and 6/10 from home. That's that tool's geometry offset to the tool eye. I'm going to back off of the tool eye. I'm going to set its X geometry offset by doing the same thing in X. Slow it down, come in X minus until I hear a beep, and you'll see the X set on the tool geometry page. It's set at minus 10 inches, 497 thousandths and 3/10. I now have a tool geometry set for tool number 1 in both X and Z. As newbies, what I'm going to ask you to do is, before you index the next tool into the ready position, I want you to put up the tool eye. The easiest way to tear up one of my tool eyes is to index a tool into the tool eye. So we're going to put it up, go back into MDI, and do a turret reverse, or forward. And we're going to set the tool geometry for the grooving tool, just like we did for the face and turn tool. It's in the active position. I bring back down the tool eye. I hand jog over close to the tool eye. It automatically, when I activate tool 2, it automatically comes up to tool 2 here, and because I'm moving Z-axis, the Z is highlighted. If I was to hit the X-axis, the X would be highlighted. I'm setting the Z, so I have to be in the Z-axis. I'm going to go to hand jog, a low rate of feed, and I'm going to go Z minus until I get the beep and the offset sets. That tool is different than the last tool. The tool geometry offset for tool 2 is minus 5 inches, 955 thousandths and 3/10.
As that's feeding across, does it auto stop?
Yes. I don't have to jerk my finger off the button when it beeps. It automatically stops and sets the tool eye, sets the tool geometry. Now I'm going to back off. This is where you've got to be careful, guys. If I go the wrong way right here, I can make that tool eye be laying down there in that chip conveyor. How important was it when we covered Cartesian coordinate systems, move these machines around? I told you guys, I want you selecting the axis that you want to move and moving the proper direction. I want to move Z-axis positive. I select Z-axis and I move in the positive direction away from my tool eye. I go in X positive, come over, get close to the tool eye, and once again I slow it down and I move X minus till I hear the beep and it sets the offset.
Is it any more accurate to index at a slower rate?
It would be. I'm within 1,000th, so I'm happy. I'm actually going to back off my wear offsets before I run a part, because we're not going to trust the accuracy of the tool eye. If it's off 10 thousandths and it's 10 thousandths in the minus direction, I'm going to scrap my first part. So we're going to back off our offsets. We'll run our part, measure it, and then come in the proper amount to size the part. That's a process that you need to get used to, because you're going to have to hold tolerances on everything you run out here in my shop. I'm going to back off the tool eye by selecting X and going in the positive direction. Put up the tool eye. I have two tools. Their geometry offsets are now set. I can go into tool 1 to the wear offsets page. Tool 1 is my face and turn tool. I'm going to put a positive 0.030 thousandths wear offset. I've just backed my tool off in the X positive direction 30 thousandths. I'm going to do the same thing in tool 2. I've backed off my grooving tool by 30 thousandths.
Is 30 thousandths typical?
Depends on the machine. Here's the deal. I can go over to the Mazak. I trust that tool eye. I open this door today, guys. I pull this tool eye down. Did anybody notice that that tool eye is whopper jawed? Whopper jaw is a technical term. Anybody notice that it's skewed? That immediately throws a red flag at me. I'm thinking it's either loose or someone's bumped it or something's going on. Okay? So I'm not trusting my tool eye at this point, so I'm going to back off 30 thousandths. If I was over on that Mazak and I've been using that Mazak for the last 3 weeks, and every time I touch off a tool I'm within 2 thousandths, I may not back off 30. I might only back off 10. Might only back off 5. If I've got plus or minus 20 thousandths on the part, I might not back off at all. And know that I'm going to be within 2 thousandths because I've got that history, I've got that experience of working with that machine and that tool eye, right? You guys see how that works?
Know your machine.
Know your machine. Know the quirks of your machine. Know the accuracies of your machine. Every machine that you walk up to is going to be a little bit different. It's going to have its own little quirks, whether it be the tool eye, maybe it doesn't even have a tool eye, and you're going to be responsible for turning a part and setting a tool geometry off of a turn diameter, which is going to be the next demonstration we're going to do over on the TL that doesn't have a tool eye. Okay? Now, one more quick thing on offsets, and then we'll move into to the next stage. We're working in offsets. We mounted tools. We're now setting up offsets. We've set those tools to what, guys? We've touched those tools off to what? The tool eye. I haven't touched those tools off to the face of the part. I programmed this part. This particular one I programmed in CAM, and I set my 0 in CAM 20 thousandths inside the face of the stock. So my program is then going to, first thing it's going to do is it's going to come down and it's going to face to 0. So I've got to somehow tell this machine where the face of my stock is, don't I? Anytime I'm using a tool eye, I'm going to have to incorporate an offset from the tool eye to the face of the part. That's what I'm going to do right now with a G54 work offset. It's another page in the offsets page. We've got tool wear, we've got tool geometry, and we've got work 0 offset. I've utilized 54 in my program. I'm going to offset the Z-axis to the face of the part. Okay? All I've got to do is take my tool over to the face of the part, I'm going to touch off the face of the part. I can spin the part, see that I'm scratching, move in just a tiny bit if I need to. I'm set. I come over my G54 in Z. I do a Z face measure. Guys, it's minus 3 inches, 288 thousandths and 3/10 from the tool eye to the face of that part. That's the offset that I just set.
Instead of using a tool eye, couldn't you just do that?
I absolutely could.
Because wouldn't it be faster?
Not necessarily. I can touch off that tool eye really quick, and then I only have to touch one tool off the face of the part. If I had 12 tools in this tool station, if I didn't use the tool eye, I'd have to touch every one of those tools off the face of the part. This way, I only have to tell it how far it is one time from the tool eye to the face of the part. Excellent question. If I back this thing off, you guys could actually take a tape measure, and from the trigger point of this tool eye to the face of this part, you could come up with this 3 inches, 288 thousandths and 3/10. It's a physical offset. It's a realistic dimension from the tool eye to the face of the part. Another speed saving of using the tool eye, if I'm running the same tools on my next setup, I put a new part in, a new program in, all I've got to do, I don't have to touch these off the tool eye again. They're already set to the tool eye, aren't they? All I've got to do is bring one tool down, touch the face of the part, and reset my Z-face measure for a G54 offset. Does that make sense? It's a little time-saving device. Guys, that concludes the offset portion. Let's take a break. Cut.